We live in a world saturated with events, changes and interactions. Leaves fall from trees, storms gather in the sky, machines break down, friendships are formed, illnesses spread, and ideas give rise to action. In all these cases, we do not merely register that something has happened, we instinctively ask why it happened. The search for explanation is one of the most fundamental features of human cognition. From early childhood onward, we seek causes. A child asks why a toy fell and why the rain began. Adults ask why a medical treatment is effective or why an economic crisis occurred. Scientists construct increasingly complex models to explain natural and social phenomena. In each of these contexts, explanation aims to uncover the causal structure of the world. Causation is more than a manner of speaking. It is a central organizing concept of thought. Without it, we could not plan for the future, learn from the past, or make sense of the present. Causation allows us to infer what will happen if we act in certain ways. It enables us to distinguish between events that merely occur and events that arise as consequences of deliberate choice. It underpins our practices of assigning responsibility, diagnosing problems, and designing technologies. Without some notion of causation, the world would appear radically disordered and unpredictable. Despite its central role, however, the nature of causation is one of the most contested issues in metaphysics. What does it mean for one event to cause another? Do causes bring about their effects by necessity, or only through regular patterns of occurrence, as many have suggested following David Hume's classical critique? Is causation a feature of the world itself or a projection imposed by human mind? Are the laws of nature binding principles that govern reality, or merely descriptive summaries of how things in fact behave? These questions lie at the heart of some of philosophy's deepest debates. At the same time, they connect metaphysics with physics, biology, psychology, and the social sciences. In this lecture, we will examine the metaphysics of causation and the laws of nature in order to understand what makes the world orderly and intelligible. In ordinary language, we use causal expressions with remarkable ease. We say that the fire caused the smoke, that a broken leg caused a limp, that bacteria caused an illness, or that rising temperatures caused a storm. Such statements appeared straightforward. The cause precedes the effect. There is some connection between them. And if the cause had not occurred, the effect would not have taken place. In everyday contexts, this way of speaking rarely gives rise to doubt. However, when philosophers begin to ask what causation itself is, this apparent simplicity quickly dissolves. Is causation a matter of physical force? Does it involve a necessary connection between events, or it is merely a pattern that we observe? Is causation a relation between events, between objects, or between processes unfolding over time? These questions invite deeper reflection. They force us to distinguish carefully between what is directly observed and what is added by inference. Consider the familiar example of fire and smoke. We never observe a necessary connection between them. What we observe is that there is fire and then that smoke appears. From this sequence, we infer that the fire produces the smoke. But is this inference justified? Or is it simply the result of repeated experience shaping our expectations? Do we perceive causation itself, or do we merely infer it from regular succession? It is precisely this question that gave rise to one of the most influential critiques of causation in the history of philosophy. David Hume, the 18th century Scottish philosopher, famously argued that we never perceive causal necessity. What experience presents to us, he claimed, is not a necessary connection between events but a constant conjunction. One type of event regularly follows another. We strike a match and a flame appears. A hammer hits the glass and the glass shatters. Thunder is heard and rain follows. Yet in none of these cases do we perceive any power of force that compels the effect to occur. All that is given to the senses is succession. Hume expressed this point with characteristic clarity when he wrote, "We never can observe any tie between cause and effect, but only the one event following the other." According to Hume, the idea of a necessary connection does not arise from perception, but from habit or custom. When we repeatedly observe that events of one kind are followed by events of another, we come to expect the effect whenever the cause appears. This expectation becomes so ingrained that we project it onto the world itself and imagine a necessary link between cause and effect. But for Hume, this necessity is not something discovered in the world, it is something supplied by the human mind. As he famously put it elsewhere, custom then is the great guide of human life. On this view, causation is not a matter of objective necessity, but of psychological projection. The world, taken in itself, may contain only patterns of regular succession. What we call causal necessity reflects the way our minds respond to these patterns, not a metaphysical bond holding events together. Hume's critique was revolutionary. It challenged the deeply rooted intuition that causes contain powers that produce their effects. It also suggested a new way of understanding the laws of nature. If causation consists only in regularities, then laws are not expressions of deep necessity, but descriptive summaries of stable patterns in experience. Many philosophers have accepted Hume's claim that empirical observation alone cannot reveal necessity. At the same time, Hume's account raises serious difficulties. If causation is merely a matter of regularity, how do we account for irregular or singular events? How can we justify counterfactual claims, such as saying that if the match had not been struck, the flame would have not happened? And how do we distinguish genuine causal relations from mere correlations? These problems motivate the search for alternative theories of causation. One way of developing Hume's insight is to treat causation as a matter of regular succession. According to this approach, known as the regularity theory of causation, causes are events that are regularly followed by their effects. To say that an event is a cause is simply to say that events of this type are always or almost always followed by events of another type. If striking a match is regularly followed by ignition, then the striking is identified as the cause of the flame. This conception of causation was given systematic form in the 19th century by John Stuart Mill, who sought to analyze causal relations in terms of uniformities of succession. On this view, causation involves no hidden necessities or metaphysical powers. It rests entirely on observable patterns. Regularity theories, therefore, have the virtue of ontological economy. They avoid speculation about unobservable connections and fit naturally with scientific practices that aim to discover stable regularities in nature. Despite these advantages, regularity theories face well-known difficulties. Most importantly, they struggle to distinguish genuine causal relations from accidental correlations. Consider a case in which the city's streetlights are switched off every morning at exactly the same time that the sun rises. These two events are constantly conjoined, yet the rising of the sun does not cause the lights to be turned off. A mere pattern of regular succession is not sufficient to establish a connection. Regularity theories also encounter problems when dealing with singular causation. We often want to say that a particular event caused another, even when such events are rare. If a meteor strikes a forest and starts a fire, this may be the only such event in many years. Nonetheless, it seems perfectly correct to say that the meteor caused the fire. Because regularity theories depend on repeated patterns, they find it difficult to account for such cases. These limitations suggest that causation cannot be reduced to regularity alone. While constant conjunction may be part of our evidence for causal relations, it cannot by itself capture what causation is. A deeper account is required. One of the most influential alternatives to regularity theories is the counterfactual theory of causation, developed in various forms by philosophers such as David Lewis. According to this approach, event A causes event B if B would not have occurred had A not occurred. Causation is thus understood in terms of counterfactual dependence. To say that striking the match caused the flame is to say that had the match not been struck, the flame would not have ignited. This idea can be stated succinctly in Lewis' canonical formulation. C depends causally on A if and only if, had A not occurred, C would not have occurred. Counterfactual analysis allows us to capture the sense in which causes make a difference. It also provides a powerful tool for distinguishing genuine causal relations from mere correlations. The rising of the sun does not cause the streetlights to turn off, because if the sun had not risen, the lights would still have gone off due to a timer or sensor. By asking what would have happened under different circumstances, counterfactual reasoning reveals the underlying structure of dependence between events. However, counterfactual theories also face significant challenges. Counterfactual claims concern hypothetical situations, ways the world might have been. Evaluating such claims requires a method for comparing possible worlds and determining which of them are most similar to be the actual one. In Lewis's framework, this involves comparing the closest possible worlds in which the antecedent of the counterfactual is true. This move raises deep metaphysical questions about the nature of possibility and similarity. Moreover, counterfactual dependence is not sufficient for causation in all cases. Situations involving multiple potential causes complicate the analysis. If a fire could have been caused either by a struck match or by a faulty electrical wire, the relevant counterfactuals become complex. In such cases, it is no longer straightforward to say which event the effect counterfactually depends on. Despite these difficulties, counterfactual theories remain highly influential. They capture a powerful intuition about causation that causes are difference makers. They also align closely with scientific reasoning and with legal and moral judgment, both of which frequently rely on counterfactual questions. In criminal law, for example, we ask whether the harm would have occurred if the defendant had acted differently. Another influential approach to causation places manipulation at the center of the analysis. According to this view, event A causes event B if manipulating A would lead to a change in B. This idea is central to interventionist theories of causation, which have gained increasing prominence in the philosophy of science. On these accounts, causation is not an inherent power residing in events or objects, but a relation that is revealed through interventions. If we can intervene on one variable and observe a systematic change in another, we have identified a causal connection. This interventionist conception of causation has been developed in detail by James Woodward in Contemporary Philosophy of Science. Woodward's approach is explicitly aligned with experimental practice. In the sciences, researchers routinely manipulate variables in order to discover causal relations. By altering conditions and observing resulting changes, they infer the underlying causal structure of a system. Interventionist theories capture this methodological core of scientific inquiry at a philosophical level. From this perspective, causation is understood less in terms of metaphysical necessity and more in terms of control and influence. To say that one factor causes another is to say that changes in the first can be used to bring about changes in the second under appropriate conditions. This makes interventionist accounts particularly attractive in fields such as biology, medicine, economics, and the social sciences, where controlled manipulation plays a central explanatory role. Nevertheless, interventionist theories also face important limitations. Not all causal relations are manipulable. The age of the universe, the occurrence of past historical events, or large-scale structural features of reality cannot be intervened upon in any straightforward sense. Moreover, the very notion of an intervention presupposes a broader causal framework, since we must already have some understanding of causal relations in order to determine what counts as a legitimate intervention. Despite these challenges, manipulability and interventionist accounts offer a pragmatic and scientifically grounded picture of causation. They shift the focus from hidden necessities to observable patterns of dependence under intervention. And in doing so, they illuminate an important dimension of how causal knowledge is actually acquired. Many philosophers have argued that causation involves real productive processes that connect causes and effects. According to mechanistic accounts, a cause is something that brings about its effect through a continuous process unfolding in time. This approach emphasizes the transmission of energy, matter, or information. Fire causes smoke, for example, because combustion releases particles that travel through the air and make the smoke visible. Mechanistic conceptions of causation offer a tangible and intuitively compelling picture. They align closely with scientific explanations that trace how effects emerge from causes through identifiable processes. In biology, chemistry, and physics, explanations frequently appeal to mechanisms. A drug lowers a fever by inhibiting specific biochemical pathways. A falling object accelerates because of the gravitational interaction between masses. In each case, the explanation identifies a chain of processes linking cause and effect. Philosophically, this way of thinking about causation appears in Wesley Salmon's account of causal processes and causal interaction, which understands causation in terms of continuous physical transmission. It is further developed in contemporary mechanistic philosophy of science by Peter Mackamer, Lindley Darden, and Karl Craver, who characterize mechanisms as organized system of entities and activities that produce phenomena. On this view, to explain a phenomenon causally is to show how it is generated by the organized interaction of components. Despite their strengths, mechanistic accounts also face challenges. Not every process is a causal process, and it is not always clear what distinguishes a genuinely causal mechanism from a mere correlation. In complex systems, multiple intertwined processes may operate simultaneously, making it difficult to isolate individual causal pathways. Moreover, mechanistic explanations are most straightforward at the physical and biological levels. When we turn to more abstract domains, such as psychological or social phenomena, purely physical mechanisms may seem insufficient to capture the relevant causal structure. Even so, mechanistic accounts capture an essential aspect of causation. They remind us that causal relations are often grounded in real, analyzable connections that unfold through time and can be investigated using scientific methods. By focusing on productive processes, these theories complement rather than replace other approaches to causation. Not all causal relations are deterministic. Many phenomena, especially in biology, psychology, and the social sciences, involve probabilistic causation. Smoking increases the probability of developing lung cancer, but it does not guarantee it. Genetic mutations raise the likelihood of certain traits, but they do not ensure their manifestation. Probabilistic causation therefore requires a more nuanced understanding than simple cause and effect determination. Some philosophers argue that probabilities reflect genuine indeterminism in the world. According to this view, events do not always have fixed outcomes. Causes may influence the likelihood of different results without fully determining which outcome will occur. This position fits naturally with interpretations of quantum mechanics that suggest that certain events are fundamentally probabilistic. Karl Popper famously defended such an outlook by interpreting probabilities as real tendencies or propensities present in the world, rather than as mere measures of ignorance. Others maintain that probabilities do not indicate indeterminism, but instead reflect limitations in our knowledge. On this epistemic interpretation, causal relations are in fact deterministic, but we lack sufficient information to predict outcomes with certainty. Probabilistic descriptions arise because complex systems involve many interacting factors whose combined effects exceed our capacity for precise calculation. Regardless of which interpretation one adopts, probabilistic causation plays a crucial role in scientific explanation. It allows us to model complex systems in which multiple causal factors interact in ways that cannot be reduced to strict determinism. By working with probabilities, science can capture patterns of influence and dependence even in domains where precise prediction is impossible. Causation is closely connected to the notion of laws of nature. Laws of nature appear to govern the behavior of the universe. They describe regularities that hold with remarkable consistency. Newton's laws describe the motion of bodies. Maxwell's equations describe electromagnetic phenomena. The laws of thermodynamics describe heat, energy, and entropy. Across the sciences, laws seem to articulate the deep order of the natural world. But what is the metaphysical status of these laws? Do they exist independently of the phenomena they describe? Do they impose order on reality, or do they merely record patterns that happen to obtain? Philosophers have developed three main approaches to these questions: Humeanism, non-Humeanism, and dispositional essentialism. According to Humeanism, laws of nature are nothing more than descriptions of regularities. The world consists of particular objects and events that behave in consistent ways, and we summarize these behaviors in the form of laws. The laws themselves do not govern the behavior of objects. Rather, objects simply behave in certain patterns. In contemporary metaphysics, this approach is often associated with the Humeanism developed by David Lewis, according to which laws are those generalizations that belong to the best systematization of the totality of facts. Humeanism offers a minimalist and elegant ontology, avoiding commitment to mysterious governing entities. However, Humeanism faces a serious explanatory challenge. If laws are merely descriptive, why does the world exhibit such a high degree of regularity? What accounts for the remarkable stability of physical constants and relations? Why do electrons always have the same charge, and why does gravity follow an inverse square law? Humeanism offers no deeper answer to these questions. On this view, laws are simply the patterns we find, not principles that explain why those patterns hold. Non-Humean approaches reject this descriptive picture. According to non-Humeanism, laws of nature express genuine necessities. They are not mere summaries, but governing principles that constrain how objects can behave. On this view, laws exist as fundamental features of reality. Electrons have their charge because the laws of nature require it. Gravitational interaction takes the form it does because the laws impose a specific structure on the world. This non-Humean conception of laws has been classically developed by D.M. Armstrong, who understands laws as necessary relations between universals. This view captures the intuition that the world is governed by real order rather than accidental regularity. At the same time, it raises difficult metaphysical questions. What kind of entities are laws if they are neither mere descriptions nor ordinary objects? Are they abstract relations existing outside space and time? And how do such laws exert their alleged governing force? Dispositional essentialism offers a third alternative. According to this view, laws of nature arise from the dispositional properties of objects themselves. Objects, possess inherent powers or capacities that determine how they behave. Salt dissolves in water because it has the disposition to do so. That disposition grounds the law that salt dissolves in water. On this account, laws are not external dictates imposed on reality, but expressions of the essential properties of things. In contemporary metaphysics, this approach is associated with philosophers such as Stephen Mumford or Alexander Bird. Dispositional essentialism integrates causation and laws in a unified framework. Causes produce their effects because objects have certain dispositions, and laws describe the regular patterns of behavior that flow from those dispositions. In this way, the view preserves the idea of necessity while avoiding the mystery of external governing laws. According to a further approach, laws of nature are best understood as relations among universals. On this view, properties such as mass, charge, or gravitational interaction are universals that stand in necessary relations to one another. The universal of mass, for example, is necessarily related to the universal of gravitational interaction. Laws of nature describe these relations. In this way, the account preserves the notion of necessity while grounding laws in properties themselves rather than external governing dictates. This theory is commonly known as the Dretske-Tooley-Armstrong account of laws. It maintains that the structure of reality includes necessary relations among universals, and that these relations explain why laws work. Laws are not mere regularities, nor are they imposed from outside the natural world. Instead, they reflect objective features of the world's metaphysical structure. The necessity associated with laws is thus built into the relations among properties themselves. The approach offers a sophisticated alternative to both Humean regularity accounts and purely dispositional views. At the same time, it comes with a significant metaphysical commitment. It requires acceptance of realism about universals, the view that properties exist as repeatable entities instantiated in multiple particular things. Since the existence of universals is itself a contested metaphysical thesis, the Dretske-Tooley-Armstrong theory inherits the broader debate surrounding universals and their ontological status. Causation does not operate exclusively at the physical level. We encounter causal relations in biology, psychology, sociology, and economics as well. At each of these levels, causal relations exhibit their own characteristic structures. In biology, causes involve biochemical pathways and regulatory mechanisms. In psychology, causes are connected with thoughts, emotions, and motivations. In social life, causes are linked to institutions, norms, and patterns of collective behavior. Some philosophers argue that higher-level causes are ultimately reducible to lower-level ones. On this reductionist view, the cause of a social phenomenon can in principle be traced back to individual behavior, which in turn can be explained in terms of neural processes and ultimately in terms of physical interactions. According to this perspective, causation properly belongs to the most fundamental level of reality, typically identified with physics, while higher-level causal talk is merely a convenient shorthand. Others reject this reductionist picture and maintain that higher-level causes are both real and irreducible. A large-scale economic recession, for example, may involve systemic factors that cannot be adequately explained by reference to individual actions alone. These higher-level causes are often described as emergent. They arise from the organization and interaction of lower-level entities, yet they possess their own explanatory power and cannot be straightforwardly eliminated in favor of more basic descriptions. In contemporary philosophy, the defense of such emergent and level-specific causation can be found, among others, in the work of Nancy Cartwright and John Dupré. The debate between reductionism and emergence is a central issue in metaphysics. It shapes how we understand the structure of reality and influences how we interpret scientific explanations across different domains. If causation operates at multiple levels, then reality itself is layered rather than flat. Each level has its own patterns of organization and its own distinctive causal structure. Causation is closely bound up with the notion of explanation. To explain something is, in many cases, to identify its causes, yet explanations can take different forms. Some explanations are particular, pointing to specific causes in individual cases. Others are general, identifying broader patterns, laws, or mechanisms that apply across many instances. If we ask why a particular plant grew unusually tall, we might explain this by noting that it received sufficient sunlight and water. This is a particular explanation. If, by contrast, we ask why plants in general grow toward light, we appeal to phototropism. This is a general explanation. Both types of explanation rely on causal relations, but they operate at different levels of generality. Explanations are also context-dependent. In medicine, a disease may be explained by the presence of a virus, by the functioning of the immune system, by genetic predispositions, or by environmental factors. These explanations do not compete with one another, rather, they operate at different explanatory levels. Understanding causation, therefore, requires recognizing the legitimacy of explanatory pluralism. Different causal accounts may be appropriate for different purposes, even when they concern the same phenomenon. Causal reasoning is not confined to scientific or philosophical contexts. It permeates everyday life. When a glass breaks, we try to determine what caused it. When a project succeeds or fails, we seek to identify the factors that contributed to the outcome. When we make plans, we anticipate future events on the basis of causal expectations. Causal reasoning also plays a central role in moral and legal judgment. When harm occurs, we ask who or what caused it. We distinguish between intentional and accidental causes. We assess responsibility by evaluating causal contributions. These practices presuppose metaphysical assumptions about how causes operate and how effects depend on them, even if such assumptions are rarely made explicit. At the same time, everyday causal reasoning is not infallible. It is subject to cognitive biases. We sometimes confuse correlation with causation or infer causal connections where none exist. Nonetheless, the ability to reason causally remains a fundamental feature of human cognition and a precondition for meaningful action in the world. Despite its central importance, causation has limits. In certain domains, causal relations become unclear, unstable, or difficult to specify. At the quantum level, events appear to occur without deterministic causes. In chaotic systems, very small differences in initial conditions can lead to vastly different outcomes. In social systems, causal relations may be so complex and interdependent that isolating individual causes becomes extremely difficult. These limitations do not undermine the concept of causation. Rather, they reveal its complexity. They show that causation is not a simple, uniform relation, but a multifaceted concept that takes different forms in different contexts. Careful philosophical analysis is therefore required to determine how causal concepts should be applied in particular domains. Having examined causation and the laws of nature, we are now in a position to turn toward the metaphysics of modality. The next stage of our inquiry will focus on possibility, necessity, and the structure of possible worlds. This transition is not accidental. Causation and modality are deeply intertwined. When we ask what caused an event, we often appeal to counterfactual considerations. What would have happened if things had been different? When we ask what is possible or necessary. When we ask what is possible or necessary, we frequently rely on assumptions about causal structure. To understand causation is, in part, to understand how the world could have unfolded otherwise. Conversely, to understand modality is to grasp the space of alternatives within which causal relations operate. Necessity, possibility, and contingency are not abstract additions to our picture of reality. They are woven into our most basic ways of explaining why things happen and why they happen as they do. In this sense, the metaphysics of causation opens the door to a deeper understanding of the world's order. It invites us to reflect not only on events and regularities, but on the underlying structure that makes the world intelligible at all. Beneath the observable succession of events lies a complex network of relations, powers, dispositions, and laws. Metaphysical inquiry seeks to articulate this network and, in doing so, to illuminate what makes the world stable enough for knowledge, action, and thought. With this perspective in place, we are ready to move beyond causation itself and to explore the modal framework within which causation is situated. The next lecture will therefore address the nature of possibility and necessity and the metaphysical structures that shape the space of what can and must be.